So for this problem, we are giving an array of digits. So inside of the digits, it is only integers, and it is only one-digit integers. So from 0 to 9. So this is what is inside, as we can see from here. The digits I is more than or equal to 0, less than or equal to 9. And the length of the digits array is at most 10 to the power of 4. Yeah, so for this problem, maybe we can use some kind of a sorting, because for sorting, the time complexity is n log n. Yeah. Now let's just continue. So we are giving this digits, and we're gonna return the largest multiple of 3. So what could be a number multiple of 3? So for example, 8, 1, 9. So the sum of them is 18. Yeah, so 18 modulo 3 is 0. Yeah, so the result gonna be 0. I'm not sure if you know about this kind of a mathematical formula. It is from high school. Yeah, so if sum of all the digits equal to sum of all the digits modulo 3 equal to 0, this means definitely this number, for example, 981, yeah, must be modulo 3, must modulo 3 equal to 0. So this is one of the properties, but for this question, it is nothing to do with that. Yeah, because we're going to use a dictionary to solve the problem. Yeah. Now let's just continue. So if there's no such answer, so we're going to return an empty array. So for this one, because the digit is 1 modulo 3 equal to 1, it is not 0, so we're going to return an empty array. But for this one, 8 plus 1 plus 9 modulo equal to 3, yeah, because it is 18, so it is okay, but we're going to return the longest number. But how can we return the longest number as a string? So we can sort it. Yeah, because for sorting, it is n log n time. It is okay. Yeah, so since the answer may not fit in a integer data type, so we're going to return the string type. Yeah, no, the returning answer must not contain unnecessary leading zeros. So this is very important. I also made a mistake by this kind of thing, because I didn't take care. So for example, yeah, I did a mistake because I didn't consider there's leading zeros for this case. Yeah, and so this case is something like this testing case. If it is always 0, so my return is a string of like 6 zeros, but actually it's gonna be only 0. Yeah, so this is one of the mistakes I did while I'm solving the problem, but definitely it's not so hard. Now, so if we're gonna use a dictionary to solve the problem, how can we do that? Because yeah, the sum of the numbers modulo 3 equal to 0. This is what we're gonna do. So what about if we just check out numbers one by one, modulo 3? What gonna be the result? So for example, 8 is just a number. So if 8 modulo 3, so what gonna be the result? It's gonna be 2. So what about 1 modulo 3? So for this 1 modulo 3, it's gonna be a 1. So what about 9? So 9 modulo 3. So 9 modulo 3, it is a 0. Yeah. So this is all the numbers we're gonna consider. We have 3 numbers, and we're gonna modulo 3 to check all the numbers. So it means we have one number, the modulo result is 2, and then we're gonna put this number 8 inside an array. So this is gonna be our dictionary. So our dictionary, the k will be 0, 1, 2, and for this one, inside of the dictionary, it's gonna be 1, and for this 0, it's gonna be 9. But we don't need to consider about the 0, because it doesn't matter if there are too many zeros. It doesn't matter, because the final result is dependent on how many ones and how many twos, right? Yeah. Now it comes to the conclusion, and we can check the first testing case. If there's only one result, the modulo result is 1, it means the length is 1. So yeah, what about if there's only one result, the modulo is 2? Yeah, so this means 1 should plus 2 times 1. This is going to be the final result. So it's going to be 3 modulo 3, so it's going to be 0. So yeah, so this means for all the numbers 8, 1, and 9, both of them is okay. So we just need to combine them together and sort them and get the final result. It's going to be 9, 8, and 1. Yeah. Now let's just check the second case, because the second case is going to be more interesting to understand the problem. Yeah. Now let's just check. So the final result is going to be, let me put it like this. The modulo result is going to be 0, 1, and 2. Yeah. So for this 8, so it's gonna be here. It's gonna be here after this 2, because 8 modulo 3 gonna be 2 and 2 gonna be the k. And this is 6 gonna be here at 0. Yeah. And what about this 7? 7 gonna be here. And what about this 1? 1 gonna be here. And what about this 0? Yeah, so this is 6 and this is 0. Yeah, so this is all our numbers. So we have 5 numbers. Yeah, now the result for the modular result is 0. We don't need to consider because it doesn't matter how many 0 is, but it matters if there are how many 1s. Yeah. Now let's just check how many 2s. There's only one number, the modular result of the modulo 3 gonna be 2, and there are 2 numbers, the modulo 3 gonna be 1. Yeah. So in this case, yeah. So in this case, we need to decide which one we're gonna choose. Yeah. Yeah, because currently, we are sure this is 2 times 1, because the length of the array is 1. This is 1, the length of the array is 2, plus 1 times 2, because the length of the array is 2. So the final result is going to be 4. Yeah. So this means 4 modulo 3 is 1. Yeah. So what we can do, we can take one number from this array, for this array 7 and 1, because the k is 1. Yeah. Or we can take 2 numbers, but it is impossible to take 2 numbers because the length of the array is only 1 for this modulo 2 result. Yeah. But for this one, we can't mostly take we can take one number from this one. Yeah, because the modulo result is 1, so we just need to take 1. Yeah. So will we take out this 7, or we will take out this 1? So definitely we will take out this 1 because 1 is smaller. Yeah. So now what is the result of our array? I mean combinations of the array. It's going to be 6, 0, 7, and 8. And for those 4 numbers, we just need to sort it in decreasing order. So it's going to be 8, 7, 6, and 0. So this is 8, 7, 6, and 0. Yeah, so I hope you understand the whole calculation. And because if you understand it, the coding is going to be much easier. Yeah, because it is just about mathematics, but we're going to use a data structure called hash table to solve the problem. Yeah. Now let's just try to solve it. So we're gonna prepare a dictionary. So I'm gonna use the default dict, and inside it's gonna be a list, and then I'm gonna check all the digits inside the digits array. So I'm gonna take the modular. So this n gonna be modular 3. Gonna append because inside it's gonna be an array, and I want to append this number. Yeah. Now let me just check, and let me just give a random return. The result is going to be an empty array, and let me just print out what is this dictionary. Yeah, so let's just check. So this dictionary is exactly what we need. So for example, for this modular result, if it is a 2, it is 8, and if it is 1, this is 1. If it is 0, it is 9. Yeah. Now our second step is to check the final result. So we're gonna use if check. So if d1, so I'm gonna use the length of d1 plus 2 times the length of the d2. So if this equals to 1, so this is our this case for this example 2. So yeah, so if the result equals to 1, because this let's just check this one, this example case 2. Yeah, so if this d1 is here, d1 is 2, I mean the length of the array is 2, and the d2, the length of the array is 1 times 2, it is 2, so it is 4. So if this result modulo 3 equals to 1, so this means we need to take out we have 2 decisions. We can take out either 2 numbers inside this array, but there's only 1 number, or we can take 1 number inside this array, 7 and 1. Of course, we will take out this one. Yeah. Now let's just do some check. So if d1, if the length of d1 more than and equal to 1. So we can sort the d1, so we're gonna unsort it. Yeah, so after sorting the d1, this is 7 and 1, it's gonna become 1 and 7, and we're gonna take out this number, so it's gonna be 0. Definitely this 0 gonna be 1, so we're gonna define it as a number. Yeah, now what are we gonna do? So we're gonna use d1 to remove this number. Yeah, so this is one case. So another case is and if this means d1 should be less than 1. Yeah, so another case is yeah, so if this d1 is more than or equal to 1, definitely we will take one number out, because one number is smaller. We don't need to take out two numbers, but if we don't have this case, we have to take out two numbers. If we want to take out two numbers, it means the d2, the length of the d2 must be less than or equal to 2. Yeah, so we're gonna use enums because there will be two numbers inside, so it's gonna be d2 dot sort, and we're gonna take out the two numbers, so it's gonna be those two numbers. Yeah, and for num in nums, and we need to remove those two numbers. Remove this num. Yeah, and another case is if we don't have those two cases, we can directly return an empty array. Yeah, so this is one case, but it's okay for us to just have a check if my coding is okay or not. I did something wrong. Yeah, let me check out the d1. Maybe there's no d1 for some of the cases. Yeah, this number should equal to d1 dot sort 0. Let me just print it out from here, maybe. Let me print out this dictionary. Yeah, because I don't know why. I think I have d1, so this is my dictionary. Yeah, let me just use sorted d1. Let me just use the sorted because I cannot sort it from here. Let me use the sorted of d1, and definitely I can get this number. Yeah, because I cannot sort in place in the dictionary. And let me also change it from here. Let me use the sorted of d2. Yeah, so this means I will take a copy and file them. Yeah, now let me just run it. Now it seems that the code is running. Yeah, although I didn't get the final result, but it is okay. Yeah, yeah, at least I can run it. Yeah, but I didn't get the final result because my result is empty. Of course, it is wrong. Yeah. How can I make the final result? So my final result is gonna be an array. It's gonna be just d0 plus d1 and plus d2, right? Yeah. Now what are we gonna do? I'm gonna turn this array into string and sort it. So it's gonna be a string of string I for I inside the array. And yeah, let me first sort it. Array dot sort reverse gonna be true. And here I'm gonna prepare the results. I'm gonna join them together and join the string. Yeah. Now let's just check what happens up to now. Yeah, now you see some strange things happens. At least we passed 1, 2, or 3. But we're gonna focus on this 2. It means we get the final result. It is okay. Yeah. So this is one of the cases. It means our coding is okay, and our calculation is okay for this problem. Yeah, but this is only one case. We need to consider another case. Yeah, yeah. So let me just copy the code from here. So if the result equal to 2, what's gonna happen? So we just need to change it from here. If d2 is more than and equal to 1, so we're gonna find the d2 and we're gonna remove from d2. Yeah. So here we're gonna change it to d1. Yeah, because we want to get the final number as large as possible. So we had better remove one number if it is possible. Otherwise, in this case, we're gonna remove two numbers. So here we're gonna change it to d1, and here gonna be d1 with remove. Yeah, and everything gonna be the same. Yeah, now let me run it. So this is gonna be the second case. Yeah, if the result gonna be equal to 2, and this is the result gonna be equal to 1. Yeah, I hope my coding is okay. But we didn't consider another case. So this is the testing case 4. So if there always be zeros, so the final result is going to be a 0. It cannot be those leading zeros. So because we cannot have leading zeros, so this means we're going to have attack. So from here we can have attack. So if array, because this is a reverse order. Yeah. So if array, it means the array exists. I mean the length of the array going to be at least 1, and the array 0 equal to 0. So if it is this case, so we're going to return a 0. So this is the testing case 4. Yeah, so if the largest number is 0, it means it has a leading 0. So we're going to return a 0. Yeah. Now let me run it. Now as you can see, it works. Let me just submit it to check if it can pass. Yeah, as you can see, it passed all testing cases, and it's pretty fast. And because the time complexity is n log n, n is 10 to the power of 10 to the power 4. Yeah, so I think this is still a good question, although it is not so hard, but it is a lot of calculations we have to consider, and there's also a lot of edge cases we have to consider. Yeah, so I hope you understand about it. That's about this problem. See you next time.